Hi, everyone. I welcome you to our ENS workshop, ENS Under the Hood, everything about naming, identity, etc. Here's Abna.eve speaking. As you all know, people know me under Abna.eve, not even my full legal name. I think it's a wonderful way to explain that your identity, your naming, wherever you go, whether it's a hackathon or in any Farcast or Twitter, etc. People identify with your name, and I think it's beautiful to see that you can bring your name various platform. And I think that's the opening for this workshop where Simon and Greg will explain everything about the .eth behind it, the future, etc., and maybe also give you some alpha for the hackathon that it's happening in roughly 45 days, what kind of projects they want to see. And yes, the stage is yours. And I just want to mention it that it's interactive. If you have any questions, just drop it in the Q&A session, raise your hand, we'll give you the mic so you can place your questions. The stage is yours and happy learning.
Hello, everybody. Hi, my name is Simon. I recently joined ENS Labs for developer relations. That's why I also bring Greg here as my backup if I say something wrong. Or yeah, but anyways, happy to be here and looking forward to come to Accra also in August. I know it's actually September, beginning of September, but I will be there already in August. But yeah, let's start with the presentation. So. Okay. I think this is good, huh? Okay.
Yeah.
All right. Yeah. So what are we talking about? Like ENS under the hood. Most people know ENS as, just name to address resolution, or like on the other side, address to name. But like there's way more in the ENS protocol or the whole the ENS system, and we want to kind of walk through some of these things. So first, like a quick reminder, what is ENS? So basically, ENS stands for Ethereum Name Service. It is a decentralized permissionless name protocol that lives on Ethereum and scales to the entire internet as of now. Soon, TM, currently the whole team is working on the Namechain and ENS V2, which will launch towards the end of the year, where then like the ENS protocol moves to the Namechain. But as of now, the protocol mainly lives on Ethereum, but it also interacts with other layer 2s, as we see later in the presentation. So very basically, ENS turns complex hex addresses into human-readable names. So you see Greg's address, which is the 0x blah, blah, blah. I mean, you probably saw that already 100 times. Basically translates to gregskrill.eth. And we can say that ENS is for blockchains or crypto, what DNS is for the internet. So nobody goes onto the internet and types 142.241.40.238 into a web browser. Like everybody just types google.com. And on the same way, we don't think that anybody should type or copy paste addresses too much. We think it should be something easy as gregskrill.eth or abna.eth, as you just said. So anywhere you can put an IP address, browsers use DNS domains, as I said, and so then anywhere you read or write an address, you should be able to use an ENS name. So this is kind of like what ENS stands for. Yes, and so ENS is not only just the system, but like I think the whole power is that it is the power is that it is integrated in so many different tools. Just see that in the speaker version we don't see the animation. But yeah, anyway, so you know that we can maybe later on do some demos. So when you use MetaMask or any other wallet, usually when we type in an ENS name, it resolves to the ENS address. So that works for MetaMask, it works for Rainbow Wallet, and that works for EtherScan, and so on and so forth. So it's pretty common. And that's all powered in the background by ENS. So usually ENS, you don't even see it's working, it just works. There are two processes that we distinguish. So the one is the forward resolution. So it's a standard one. So you see NIC.ETH that resolves here two different two addresses. They are not different, but on different chains. And then we also have like this reverse resolution where we have an address that resolves two names. These are two different things. When working professionally with ENS, it's important to know that the reverse resolution, or the so-called primary name, needs to be set explicitly. Or maybe in more computer science terms, it's many to one relationship. So like one address can only point to one primary name, whereas one name can point to multiple addresses. And also multiple name can point to the same address, but there's only one primary name. It's important because so that when we have an address, we want to be sure that it resolves properly. Okay. As I said, like ENS is also used on different applications. So we see that later on, these widgets that we see here, they can be used. So for example, when you program your application and you use VM or Rainbow and all that cool stuff, Rainbow Kit, then ENS integration is usually already there out of the box. Yes, so and also we think this ENS names is more than just like a name, and it's also even more like a username. We already understand that they are portable. So the cool thing about ENS is once you have your .eth address, everywhere it is supported, and like ENS is supported, and that's actually almost everywhere in the Ethereum ecosystem, and even more and coming more and more into the broader crypto ecosystem. The names are supported. So when you see here, like Greg Skrill, or Greg has already has just Greg Skrill with ETH, but then on all of these apps or dApps, he has already a profile, so to say. That's because they are portable. So it's just not a username, it's a profile. And when we go on app.ens.domains, we can look up the actual entries. And when we look here at Greg's entry, then we see that he has like a profile picture set, like there is a bio set, there is even like a city set, there's the Twitter account or the X account, the GitHub account, and addresses for different chains. Also other records. We dive deeper into this later, but there is a lot of different stuff that we can put onto an ENS name. So it's just not only name to address, but there are also like text records. There's also like a whole ownership thing behind the scenes, like who owns it, who owns the name, who can manage the name, and there are even subnames. You can look into that later. The one thing that I think a lot of people also don't get right with the concept of ENS is like that it's not only just one name to one address that resolves, but we can like behind one name, so this is my example, SES2DEF, I can set different addresses. So here, for example, like on Ethereum, it's resolves to the 0x54 blah 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 address, but I can also set the Solana address, which is different, and also I can set a different address on Arbitrum. So that's actually important because a lot of people don't really set these L2 names or like even non-EVM name addresses correctly, but ENS has that power. So in the end, the cool thing is that I can tell anybody who wants to send me money to send it to ses.eth, regardless if they are on Ethereum base or Solana or whatever. You can also add a Bitcoin address. So in the end, it's then the application to interpret which address they wanna resolve. Also, something that I think is interesting, we can set the avatar, and we can even set it to an NFT that I actually own. So this is it's an NFT from a Ghanaian artist actually that I bought at some point, and I can set it here, and I just need to put that avatar record to that thing, and then like in the background the system looks, do I own that NFT, and if yes, then I set it as a profile picture. That's very convenient. But also what a lot of people don't know that we see on the next slide is that it's not only like the .eth addresses, but also like we can bring in .box addresses. That's one tool that pretty neatly works with ENS for managing like other domains, but also like any .com or .org or whatever domain actually can be imported here as long as it is it supports the DNSSEC standard. This is a precondition. But yeah, what I see a lot of people actually have, or one of the critiques that people have with ENS, like there's some like cost to it. So like the ENS name costs some money per year, but we even have subdomains. I touched on this before. So for example, on Base, probably the most prominent subdomain provider that we have, I think the names are free. So everybody can just like claim their base names, and which is basically free, and that works more or less the same in ENS as like a .eth name. So it's pretty cool. So most people probably know Jesse Pollack with his .base.eth address, but also properly set with avatar and then a bio, the X accounts and GitHub account as Greg has also set on his address. Okay, cool. So why do all the things? So as I said, like we think that crypto power experience should never interact with hex addresses, as nobody interacts with IP addresses. There are also like security considerations in that regard. Yes, because the security, like with a hex address, we might make copy paste errors, but like with ENS addresses that there's no typo, like the address either resolves. But yes, that says that Ethereum by itself stands like this, and now you understand where the logo is coming from. So ENS is basically kind of this convenience shell around Ethereum, like a user experience shell that makes it easier to interact with Ethereum. Okay, cool. Do we have any questions so far? No. Okay, I go forward. All right. Yeah. So how does ENS work? So think of ENS, especially V1, as just like as a registry, maybe like a table where we have a name that has a resolver. The resolver is not necessarily is not the name, it's not the address that it resolves, but it's like it's a smart contract that's configured that we know we can ask to resolve the name. And different names have different resolvers. So we look at base.eth, which has a different resolver, and this resolver basically helps with the subdomains. Yeah, so on this 0x4976 resolver, which is the public resolver, when we ask for Skriloff, it returns us basically an array with addresses that are configured for Skriloff, or we can ask for that array. You can also have like some text records. So as I said, like there was the avatar, the description, and even more. I think the IP or the X accounts and the GitHub account are also stored in text records. So we have address records, text records, and also the content hash. We look at the content hash later. But the content hash basically says there's an IPFS hash where we can upload a static file or static website to IPFS and then link it to ENS, which generates these unruggable static websites. I'll show that a little bit later. Yes, and as we looked at the one from Base, there are also off-chain resolvers, so that they're not the public ones, it's the off-chain resolvers. And this through the protocol called a CCIP read. So whenever someone tries to resolve like Jesse.base.eth, the smart contracts on Ethereum mainnet would revert for that read call with an off-chain lookup error, so to say. But and then in the front end, we can look into this off-chain lookup, and it will tell us where to look up. Yeah. And so basically, here we see the UML diagram. So it tries to resolve it, it reverts, and it asks the gateway that can resolve it, and then it can get it from a database or it can get it from an L2 and returns that data. But here it's very important that the data that is returned, it comes with a signature that then can again be verified against the smart contract, and then it's to return the data, because like it could be that somewhere here, you know, like the API is broken or hacked or whatever, but like a hacked API cannot return a data that can be verified here. So it's a pretty secure way of getting off-chain data. There's a whole specification to read about. It's a cool system, but it is basically how it works. So we can have resolvers that also resolve from off-chain sources or L2s as of now.
Simon?
Yeah, there was a question,
Sure.
no?
Yeah, there are two questions. One, I will read that from Ajay Michael. He's asking, how scalable is ENS when we consider potential millions of name lookups happening across L2s and multi-chain ecosystems?
Ooh, I like that. That's a cool question. Thank you. So the thing is, let's think about scalability. So when we interact with Ethereum, like Ethereum doesn't have any scaling issues. Uh, I mean, like the only scaling issue that we have with Ethereum, actually, it's a pretty big one, is the gas prices. But like to register ENS names, like it works on Ethereum, and as long as Ethereum works, you can register and manage your Ethereum your names. So in the 10 years of anniversary that we will celebrate next week, I think one of the claims is that Ethereum has an uptime of 100%, which is actually quite impressive. When you look at traditional systems that struggle to keep up with uptime of 99.99% or something like that. But Ethereum has up to 100%. So like that's the cool thing about the decentralized technology, that it is on the quality of Ethereum, is that it basically never goes down. So even like if a billion of people start to interact with Ethereum, the only thing that happens is that gas prices spike. I mean, that's inconvenient, but like with ENS, I would say mostly people read from ENS, they don't write to ENS. So as long as you own your name and you have your addresses configured, like regardless how high the gas cost is, the reading on the on-chain reading is always kind of free. Like I put that in brackets because it's not 100% free. Usually when we use MetaMask, we read from Ethereum through Infura gateways, and they might, or Infura nodes, and they might go down. And as a developer, you might use, you know, Alchemy or other providers that give you JSON RPC access. Also, those can go down, but you always have the option to run your own, Ethereum node at your home, and that one that just syncs with the network, and you can always read from it. So that's not an issue. So having said that, sure, there are, like, if you think of the whole system, and later on there's also like an ENS node, and also that helps with retrieving that data. They can go down, but the system, like the core of the protocol, cannot go down, or can only go down if Ethereum goes down or the smart contracts are hacked. But both are extremely unlikely. Does that answer the question?
Michael, I gave you the permission to talk, so if you want to add or speak, feel free. So.
Oh, okay. Hello, please can you hear me?
Hi,
Yes, we
yes.
can hear you.
Oh, okay. Yeah, it does answer the question a bit, because I know, as you said, there's been work being done around the TCP, the read to offload resolution. But I'm wondering whether there's trade-offs like latency, trust assumptions, and maybe some decentralization risk.
Okay,
Is
also
there,
there.
yeah, is there like a roadmap or approach for making it like truly scalable and multi-chain?
Yes, so yeah, I'm sure there are risks involved. Greg, do you want to jump in?
Yeah, I can also add more to this. So it's a good question. There are lots of different ways to implement CCIP read. And what you see in the kind of two arrows. So you have the implementation specific logic on the right side, and then the kind of callback verification on the left side. Those two things can be customized to be completely trustless in that they read a storage slot from a layer 2 RPC URL, and then they verify that against the like state root of the layer 2 on layer 1 in kind of the bridge contract. So it gets pretty technical, but in that best implementation, it means that anybody can run their own gateway actually, and you can do ENS requests to your own gateway instead of, you know, a public one that anybody else runs. So this makes it basically the same like scalability characteristics that we have for L1 and L2s today. Like Simon said, if you're using an RPC URL and it stops working for some reason, you know, you get rate limited or it's just a bad provider, you can always run your own, or you can always run another one. And so for as long as people want to use ENS, then somebody will offer a better and faster solution. And again, like the beauty of all of this in the best implementation is that it's completely trustless and anybody can run their own. So from a scalability side, it's pretty flexible.
Okay, thank you. I'll look more into that.
Yeah. Also, if you start to look into, I mean, there's the roadmap for Namechain is maybe interesting here, which should also help with that, and also, but generally said, as Greg also elaborated on, there is some risk assumptions going with CCIP read, or which are mostly used for subnames. But if you really want to kind of stay on the safe side, then the recommendation is to actually buy a .eth domain, a second level .eth domain like Greg Skrill.eth, Abner.eth, or whatever. So you can maybe, I don't know if Adai or Michael Adai.eth is available. But if you have a really a .eth domain, then you have like the highest form of decentralization and you know, censorship resistance and everything cool. Okay.
All right, thank you.
Yeah, thanks for the question. Let's move on. So what can we build? Like as said before, like anywhere you build an app, you show a hex address, it should use an ENS name. So that's what we want to see actually for the hackathon, or also for your side project. These are hackathon slides. So like, yeah, for AI, we might want to have you know, usernames. We can have usernames for your AI bots, text records, and so on and so forth. For social, we can also work with username avatars. Maybe even have like you know, arbitrary text records that integrate into your application. For a wallet, we can use the avatar, the primary names, the content hash. I'll show you quickly. And there is also the Durin thing that you might want to get yourself familiar before the ETHAccra hackathon, and Greg will give a quick speedrun later about that, which is a way to emit your own subnames. So I know Abner.eth, or I know ETHAccra.eth can maybe start to emit subnames like Michael.ETHAccra.eth and Cynthia.ETHAccra.eth and whatever. And so when you build your own application, let's say you build a wallet that's targeted at people in West Africa, you might not want you say that everybody needs to pay this money to buy a .eth address. You can just buy one .eth address for your project and then start to give the subnames to your users as an onboarding, and then with that, those subnames, they work across the stack as it would. Yeah, so there's secure code, and last but not least, yeah, there's a documentation page that you can look up, and there's also the ENS developers Telegram that you can join. So I would actually recommend to join that one, because that's a cool group with smart developers, and you can ask questions there 24/7. And we try to answer them also as quick as possible. Yeah, I'll leave that slide open for 5, 4, 3, 2, 1 seconds. Yeah, Abna?
I think someone has raised his hand. He wants to place his question. Samuel, I allow you to speak. Is that okay?
It's fine for me.
Okay.
Hello?
Yes,
Hi.
Simon, we
Hello?
can hear you.
Good evening, and great to be here. My question goes to Simon, and it's about security, because assigning identity to wallet addresses is a big no for me. And doing this with ENS kind of like giving hackers or attackers an easy way to do. And with the case of ZK, which is trying to hide identity of developers, why should we consider this as a good practice to do?
That's a very good question. That brings me actually so to some demos. So basically what I have with my ENS name, or Abna has, or like most people here, also Greg, with the public ENS names, these are public profiles, and I think it's important to be aware that they are actually public. And for me, it's clear, like whatever I do on SCS.eth with the addresses that are there, that's something I also am comfortable with if the whole world knows, you know. So you can look me up and you see like there's some money there, and then do some stuff on chain. There are even apps, cool apps, like interface that you can actually track people and see what they're doing. So that's one thing. But sure, like I would not want to, for example, have my salary being paid through my public ENS address, because then everybody sees my salary, and I don't know, like in Switzerland, we are very secretive about money in general, but I think it's anyways good practice that not everybody knows how much money that everybody has. So for that, actually, I want to quickly go to something else. Let me share my screen again. And this time the whole screen. Do you see my whole screen, huh? Yeah. So
Yes,
this
we
actually,
see.
so this is actually an interesting project. It's called the Fluid Key. And now when you see, for example, my Ethereum address here is like 0x594. Okay. And then I refresh. And then you see it goes a little bit dark. And then it gives a new one, 0x1EB. So this is a very cool feature, and we saw like also people at ETH Global Con to play around with this. It's called the so-called stealth addresses. There are also like documentation about this, but in general, what it does with stealth addresses, and ENS actually supports, is that when I have that the resolver, you know, that you see here, this resolver set up correctly every 10 seconds or so, or 15 seconds or so, creates a new address. And that's cool, but so on the blockchain, these addresses don't have anything to do with each other, like they're fresh addresses, they're just there. But Fluid Key, they created a system that with one primary key, I can manage all these addresses, but only the one that owns that primary key. So that's actually pretty cool, and I want to actually at some point set it up, something like so pay.scs.eth, so then I can just send this ENS name to the people that want to pay me, and everybody that wants to pay me receives a new address, and only me knows that these are actually my addresses, and nobody else. That's actually pretty cool, and I think that resolves privacy issues to a high degree. I think the other thing that's also worth mentioning is when we look at my name, is the ownership. Oh, actually, or maybe that's actually the wrong example. But we can have like different owner and manager. Yeah, here you have it. So you see here I have a different owner set and a different manager. So, and the idea is that you set the owner to a cold wallet. that you don't interact with every day, and then you have the manager maybe in your hot wallet, you know, in your MetaMask or Rainbow wallet that you have on your phone. And then, as it happens with everybody that interacts in crypto from time to time, maybe we click on the wrong stuff, and the current our hot wallet can get emptied because we were not careful with seeing what we sign. Generally speaking, be careful what you sign, but it happens, you know. And so when this would happen, and I would lose access to this address, or that one, like a hacker gets access to this address, then with that, I can kind of like bring my owner address, which is way more secure, and I do not interact much into play, and just remove and then kick out the manager and set other records. And that's a cool thing to still go through my profile, and being the owner and have the manager separated. Does that answer your question, Daniel? I think was your name. No, Samuel. Samuel, sorry.
Yes, thank you.
Okay, thank you. All right, then let me go through two more of these examples that I prepared here. So as I said before, and we looked at the addresses, so you see Greg has a different addresses set, but what I wanted to also go into is the content hash. So the cool thing about the content hash is that we can deploy a website on IPFS and then add that content hash here to the ENS name, and which then gives this, you know, the gregskrill.eth.limo. So this is just static HTML. But the cool thing here is like this is very, very unruggable, and also like that scales like crazy because it's IPFS again, like they're distributed nodes, and it's very hard to attack something like that. I mean, we saw it recently, like this, like supply chain attacks where people were able to add some you know, arbitrary JavaScript into front-end websites. With that setup here, that makes it much harder because the IPFS hash represents a hash of the file, and that hash would change if someone would try to inject something. That's actually a very cool way of creating decentralized websites. I think I have it here. No. So that's that. So you can go to eth.limo. And that's a whole thing about like how to do it, who uses it, blah, 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 blah. So it's also a project that's worth talking about. So we looked at this, I looked at this. Yeah, then another cool project I like to highlight is like Nscribe. So the idea is to really have to name also contracts that are deployed to any chain actually, and then we can look it up. Add to the Nscribe ETH. Did I type it wrongly? Yeah. Scribe. Yeah, better. Yeah, so they just set their ENS names, primary names for their contract addresses. It's a pretty cool tool that I like that helps doing this. Yeah, Durin, we looked at it. So with Durin, you can create your own subnames or ENS subdomains. That we see that often at hackathons, people actually implement this. So as a preparation, maybe for ETHAccra to be ready, go through this and find out how to use subnames, because you can do a lot of cool stuff with it. Then ENS node, the thing to query data from ENS. So either you can do this either through the graph, the subgraph, but that's only for Ethereum mainnet. But like with the ENS node, there is also like subname support and so on and so forth. So yeah, also a very cool project that helps a lot with building. And then maybe a quick, also like for the Ethereum follow protocol, also built on top of ENS, that we can follow people here and see what they do. So as I said before, like see, these are like all public stuff. So we see, for example, like that Mike Dermays from Rainbow wallet for just bought some Moose coin for $10. yeah, and that Rafi bought something on OpenSea and so on and so forth. So it's actually it's pretty cool. So this is actually powered by interface. As I said, like it's a tool to stalk people on chain. But yeah, we do that with our public profiles. But obviously, we also want to have like private profiles that we are not that public about. All right, questions? Otherwise, I go into live coding. I do maybe 10 minutes. Okay.
I think you can go to live coding. It's okay.
Okay. All right. All right. Okay. Oh. Actually, I think I need to run one password. Okay, just the background. So I don't know. So we have this Scaffold-ETH. They also will give workshops at ETHAccra. It's a cool thing to get started. But what I'm usually do is just like do npx create ETH latest, and then I go to terminal and just copy paste that thing. And what it does in the background is like it spins up a full stack Web3 or like Ethereum development thing, and it already has ENS integrated. So while it's installing, what did I say? ETHAccra, ENS. Okay, I can actually already start vibe coding in. Yeah, so what it does, so we have like it bootstraps this README file here, where you can read everything, and then by default it has two packages like Hardhat or Next.js. But yeah, sometimes it makes it sometimes cool to maybe start with already subgraph support or with Ponder support, or ES20. There are even more extensions. So it's actually pretty cool to quickly spin up any website or like any tool. So let's see. It should not take too much time. Here we go. Nice. Okay. So let's follow just the instruction. Basically, actually, maybe I do that directly here so that I can also add AI for help, which is in the first terminal, I do yarn chain. I do another terminal where I do yarn deploy. Then yarn start. And then I already have like a local development environment set up. Okay. And yeah, what's already here is that, oops. So that when we use this, it already works. See, I can go with SS to D. It already automatically gets my profile picture and gets the address out. So this is already given. Thanks to this the address input here, as you can see. Yes. So basically, that's all you need to go to get started with ENS. Maybe, I don't know, Greg, if you can quickly show the Durin subnames in 10 minutes, that might be super interesting also.
Yeah. So I have a number of things that I was going to walk through. I probably will not have time to get to all of them at this point, but I will.
But Greg, no worries. I mean, if you need more time, just take your time. I mean,
Cool.
we are flexible. It's up to you, to your schedule.
Good. Yeah. I will start and see how we're feeling. But before I do, I'm going to start sharing my screen while I figure that out. If anybody has questions, now is a good kind of point to stop and ask. But if not, I will get this sorted in just a second. Okay, and sorry if you hear background music. I'm in New York and somebody's playing music very loud on the street in a car right now. Okay, so can you all see my screen, this ENS design system? Great. And you can hear me okay? Awesome. So there are a few things that I want to walk through. This is my kind of, oh, it's getting louder. This is my kind of quick agenda. So I'm going to show you Thorin, our component library and design system that will help you build very easily and quickly front-end applications. I will show you our front-end template, which basically uses Thorin and shows you how to, again, move quickly in a front-end application. And then I'll talk a little bit about subdomains and some tools that we have around that. And maybe a full integration, but I don't know with timing. So let me start by saying, if you're building a front-end application, you don't want to be bogged down by like building each little component and making sure things look nice. And so we have Thorin to kind of help with that. It is a design system that gives you a bunch of components like buttons and inputs and cards and all these different things that will make it very easy for you to build interfaces that work well and feel good and look nice for your users. And I think that is very important. If you are building with, AI tools, you can add this thing called Context 7 to your LLMs. And this is trained on Thorin. And so you should be able to say like, build an application or build a form that uses an input from Thorin with Context 7, and it will kind of use the docs to build that based on all the available data. So if you're into AI coding, I highly recommend Context 7. This website kind of walks you through how to use it, and Thorin is already in here. Cool. Moving forward, the best example of using Thorin is probably in this front-end template. I will drop a link. Actually, I don't know if there's a chat for me to drop a link in, but maybe just look at the link here and start for later. But it's basically an application with very popular tech stack, Next.js, Thorin, WAGMI, VM, RainbowKit, and so on. And this will give you a good starting ground for building front-end applications. So now that we have that, I'm just going to show you kind of what it looks like. I already have the front-end template open on the side for me. And I'm going to run it over here. It looks very basic. It's just so that you can install something and get coding immediately. And this will get started now. Cool. There are two examples of Thorin using ENS in a way that you might want to in your application. The first is what Simon mentioned in the slides early on. The idea with ENS is that anywhere you see an address, you're either reading an address from a web page or you're typing one in, you should be able to use an ENS name instead. And so as an example, you might have an input box somewhere in your app that transfers assets to a different wallet, or looks for a token, or looks for a contract, or anything like that. And that input should always support ENS. And so just to show you, this is how it would work in reality. You can type a name. You can also type an address. It's just like a universal input box. The code for that is very simple. Built into, I was playing around with this earlier, so there are some, I guess, dependency errors, but we can ignore that because it works. Built into all of the popular libraries that you use today, like WAGMI and VM, is built-in ENS functionality. And so really all that we're doing here is calling use ENS address once something is in the input box that could potentially be an ENS name. One thing that I'll call out here, a common misconception, is that people think ENS is only .eth. But again, as Simon mentioned earlier, ENS supports .eth names as kind of the native on-chain TLD, and also supports all DNS TLDs. So that's .com, .xyz, .io, really anything can be a valid ENS name. And so in a implementation like this, you want to make sure that you're trying to resolve a name as soon as there's a string with a dot, like a dot separated string. So as soon as you see something like this, you should assume that it can be an ENS name and try to resolve it. So what this means is the code shouldn't just be like, if the string includes .eth, check if it can be resolved to an address. It's any dot separated string. And so yeah, the implementation is quite simple. If there's a dot in the input, we will run this hook to see if there's an ENS address. If not, then we pass it undefined and it won't look up that address. Another thing that I want to point out that people often forget, and maybe I should make this a bit bigger, is all ENS resolution starts from Ethereum mainnet, or let's say from L1. So Ethereum mainnet or Sepolia for a testnet. And the reason this has to happen is because the ENS registry is on layer 1, and that serves as kind of the thing that can gather any data you need. That's the starting point for everything. And so people will try and leave this out, and they get confused why it's not working. But the reason is because if your user is connected to base, for example, and they run this use ENS address hook, it will look for the ENS registry on base, but that doesn't exist. And so regardless of what chain your user is on, ENS resolution should always start from the layer 1. So in this case, chain ID 1 is for mainnet, or in WAGMI, you could always do sepolia.id for testnet resolution. So very simple. This is an example of writing an ENS name. And then the other thing that I mentioned is reading an ENS name. So for example, on Etherscan, this is what, again, Simon showed before. It is much easier to understand what's happening in a transaction like this, when Greg Skrill is sending something out to zk.ens.gregskrill.eth. This is a smart contract. Or if I'm transferring tokens to somebody else. An ENS name is much easier to see kind of what's happening. It brings more context to any given transaction. And the way you do that is, instead of a use ENS address hook, again, very simple, it is just a use, oh, that's the wrong file. It is simply a use ENS name hook. And I guess it's a little bit abstracted in here. But what this looks like is I have a connect button. I'm not connected right now. If I do connect my wallet, then boom, it kind of recognizes me as gregskrill.eth. That is my portable Web3 identity, my global profile. And just to show you again, in WAGMI, this is use ENS name. It takes an address and it gives you a result of the name itself. I will stop here before I kind of talk about subdomains and more L2 stuff. Do these code examples give you a good understanding of what's happening based on everything that Simon talked about in the slides, or is there anything confusing yet? I'll wait a few seconds. Okay, no questions, great. Then I will talk about subdomains. Subdomains are a big part of ENS these days. The reason is because some of the scalability questions that somebody was asking before. You know, normal .eth names, so like gregskrill.eth names, we call that a second level domain because the top level is .eth, the second level is gregskrill. So gregskrill.eth is a second level domain. Those are on mainnet Ethereum, which is great. That is the most decentralized type of name you could possibly have. But in order to get that, you have to pay Ethereum gas fees, which sometimes can be high. And so subdomains allow you to issue, or it's possible to issue subdomains to your users on layer 2 chains or off-chain, or basically in a more flexible way that allows your users to acquire a name for free or for very cheap, kind of however you want. This is all powered by a technology called CCIP read, which again, Simon mentioned earlier. So I don't necessarily plan to walk through the details of how that works again here. But CCIP read is what powers both off-chain subnames and L2 subnames. Given this is a crypto hackathon and we like things being on chain, we will stick to a demo of on-chain L2 subnames. And that brings us back to Durin. So Durin is basically a toolkit that makes it easy to create subdomains on any layer 2 of your choice for an ENS name. I will walk through it quickly, and for the sake of time, I'm not going to actually deploy it, but I will walk through it so that it can be as easy as possible if you go to do it. This would be useful if you're building an application that you have new users sign up to that likely wouldn't already have an ENS name. One point of confusion that I often see is, like, regardless of who signs up to the application wants to give their users a subdomain, which is cool. You know, users are used to creating a username in each application, but the beauty of ENS, again, is that's your portable Web3 username, your portable profile. And so if your user already has a .eth name or some other name, you really don't need to give them a subname. It's simply a onboarding tool so that your users never have to experience a hex address. So that's just like the way I would think about it if I was building something and trying to onboard users. Subdomains are not a product that everybody needs to have. It's simply a solution if a new user doesn't already have a name. What this allows you to do is connect a name that you have on L1, again, mainnet or Sepolia, and choose an L2 chain to pair that with. There are a number of options here, also testnet or mainnet. And it kind of takes care of that CCIP read part that we talked about earlier, that off-chain gateway and that custom L1 resolver contract. That's taken care of for you with Durin. And what this walks you through, maybe I'll just deploy half of it because I'll deploy the easy part. Over here, if I deploy this registry, what's happening is on base Sepolia, it just deployed a contract that allows you to register names under alice.eth. And this is very easy. You know, it has everything that you could possibly need to create sub.alice.eth and kind of do a bunch of flexible things on top of that. The next step is to connect that L2 registry to your L1 name. This is kind of the CCIP read part. And then it asks you to deploy a registrar. A registrar is a smart contract that your users actually interact with directly, and it kind of makes the system more flexible. So what this means is that I can't, as a user, just go to this L2 registry right now and call the register function. Or like, well, there is no register function. It's kind of a more technical abstraction on top of registrations. And what you have to do is deploy a registrar contract that under the hood registers names in this registry. And what that looks like is this. This is what has a register function, and it looks more complicated than it is just because of all the comments. It's actually very few lines of code without all of these comments. And when you register a name, it basically creates a node, as we call it, in the registry. And that is kind of creating the ENS name as an NFT. The reason, again, we have to do this is because some people might want to build subdomains that users have to pay for. Like you charge your user to register sub.name.eth. Others might want to require that you own some unrelated NFT, or basically customize the business logic, as we would call it, of this registrar contract. And so we say, okay, let's create a standard registry that is fairly unopinionated and allow people to customize this registrar, which like pushes calls through to the registry. And so this is your opportunity to really customize things any way you want. And yeah, build it into your application, build it into your other contracts, and so on. Once you deploy that, you would basically, as the admin of this registry, call add registrar to approve your contract, the ability to register names in the base registry. And then you're good to go. Users can register names through whatever logic you decide to codify over here. And then you have subdomains on a layer 2 network of your choice. This website kind of walks you through all of the steps alongside the repo, which is also open source and kind of walks you through the steps. So whichever one you decide to go through, a little bit more technical or a little bit more abstracted. But the starting point for both of those is durin.dev. I'll pause here for questions, and then I will just talk about one more thing before we wrap up if there are none. Okay, great. Our audience is all experts today with no questions. Okay, the last thing that I will talk about kind of builds on top of the layer 2 subdomains and is this idea of a primary name on a layer 2. So Simon talked about primary names earlier. It's basically the ability to request a name for a given address. And this is useful if you are ever showing, historic transactions for an address, or really anywhere you have an address on a page, you'd want to show that as an ENS name. The way you do that is by fetching the user's primary name. Today on mainnet, at least, that ability is only possible on L1 Ethereum. And so even if your users have a subdomain on layer 2, it's actually not super usable unless they make an L1 transaction. And so that's what we're changing, and that's something cool that you guys can hack on, and actually will be live by the time ETHAccra kind of begins. It should be live in like 10 days based on the latest information. I will walk you through how that works. And it's basically the same way as it works on mainnet Ethereum, but deployed to Base, Optimism, Arbitrum, Scroll, and Linea. This document here, primary names under docs.ens.domains, walks through the normal primary name stuff and then has a section on L2 primary names. There are, for the first time, a set of ENS contracts deployed to all of these L2 chains that have a similar interface of set name that a user can set their primary name directly, or set name for address with signature that allows you as a developer to basically sponsor the setting of a primary name for your users. And this becomes really useful because you can finally have an end-to-end experience on an L2 for ENS. And so this means a user can sign up to your application that's built on Base, for example. You can issue them a subdomain on Base if they don't already have an ENS name. And then you can set their primary name on Base as part of your registration transaction. And so whenever they go around the Ethereum ecosystem to other apps that are built on Base, they would be able to show that user as whatever name you've registered for them, instead of just a random hex address. So to recap, it becomes this kind of portable Web3 profile and is not just a name that you can type in to get to an address, but truly anywhere this person goes around the Ethereum ecosystem, they are basically identified as this name. So primary names really close the loop on making an ENS a portable Web3 identity. And so it's a very important part of the stack that I think you'll have fun playing with. So it is available on all of those test nets that I mentioned right now, with the relevant contracts linked in the same docs page. And again, by the time the hackathon starts, it will also be live on mainnet. So that's something that we'd be excited to see, kind of an end-to-end ENS experience on L2s, between customizing a smart contract to register names, setting the primary name, and showing that in an application. But yeah, that is everything that I wanted to walk through today. Thank you guys for staying a few minutes late. If there are any questions, I'm sure we can take it during the next few minutes. But I guess I'll hand it back to Simon or Abna to close us out if there are none.
Thank you so much. Can you hear me?
Yes.
Yes. Hey, Greg, thank you so much. I'm really excited. I learned a lot today. Wow. I have to be honest.
Awesome.
But I would love to hack if I'm not organizing. But hey, anyone of the audience, you have questions, I think we will also start loading up like documentation on our ETHAccra dashboard. But if you have any questions, feel free. Don't be shy. I think now it's the time. Michael has another question. Yeah, feel free. The stage is yours.
Okay, please can you hear me?
Yes, we can hear you.
Okay, so how you spoke about the ENS registry tracking the owner's node. So whether it's a top level name like michael.eth or like a subdomain like dev.michael.eth. But let's say once I start handing out these subdomains, say in a DAO or community project, how do I manage trust and control, like without giving full central bank? Because like I don't want to be the god admin of my own namespace and end up with people DMing me like, hey bro, I lost my subdomain, help.
Yeah, so I think high level there are different options of what you can do. Durin is just assuming you are thinking about doing this on a layer 2, Durin is just a starting point. By default, if somebody registers a name, then it is fully theirs, and I don't think I'd have to refresh myself with the exact code, but I don't think that the owner of the contract can actually do anything and take the name back. It would be fully like trustless. If somebody owns dev.michael.eth, then michael.eth can't necessarily like take back dev, at least not easily. And if you want to change that, you certainly could, because yeah, Durin is just a starting point and allows you to customize really anything you want. Oh, I stopped sharing my screen already. But I would recommend looking through the smart contracts for Durin, which you can also find on durin.dev. There's a link to the GitHub repo. And if you wanted to customize it so that there's an admin who can revoke names, you can certainly do that. They're both valid ENS names. They will work the same way in terms of resolution. And so it's kind of like however you want to do it, it's possible. ENS is extremely flexible, almost sometimes too much, to where people ask, like, can I do this or this, or should I do this or this? I was like, yes. And it's like, you can pretty much do anything you want. And so sometimes that is almost overwhelming. But yeah, basically, if you want to have admin control, you can add that in. I don't think it's in Durin today.
Alright,
but if
great.
you want it to be permissionless, you can also do that.
Great. So do you also think subdomains could like evolve into like decentralized identity primitives? Like the Michael, like dev.michael.eth becoming a Web3 email login or like a voting identity across like dApps? Or is the layer
Absolutely.
too low for that kind of abstraction?
Yeah, so I would say ENS is very much part of the kind of Web3 identity stack. You mentioned email and websites as two things. There are a few things that I can share about that. There's this project called ZK Email, which builds things not necessarily all related to ENS, but they built a project recently that allows you to do something about using your ENS as an email in a kind of like trustless, provable way. I don't know the details about it, but I would kind of look into that if you're curious about the email side of things. As far as websites go, I have a better example for you. So any ENS name can attach what we call a content hash to it. The content hash is basically a pointer to some sort of decentralized storage on IPFS or Arweave or a couple other networks. It looks something like this. This is an IPFS hash. And so if you attach an IPFS hash to your name, that kind of becomes a decentralized website because the ENS name is like the website domain and the content hash points to the value of it. And since .eth is not, you're not able to look up a .eth name in browsers by default, like I can't just do this, there are a number of gateways that exist to where they basically abstract that for you. So an example would be, right, we have vitalik.eth. I want to look up the content hash, so I will add .limo. ETH.limo is what Simon mentioned before, is kind of that oh, Vitalik's dark mode thing is broken. But yeah, ETH.limo is basically a gateway. And so what it does under the hood is it sees I'm requesting Vitalik.eth. It resolves the content hash for that. It resolves that data from IPFS, and it serves that under a nice, convenient domain here. And so whenever Vitalik shares a blog post on Twitter, he will share a link to vitalik.eth.limo. And that's serving the content from IPFS. And so a lot of people say a website is part of your identity. This is basically using ENS as that decentralized identity and relating it to the website and the name and kind of tying everything together.
I see. I mean that was solid. That was solid. I really appreciate you breaking it down like that. I didn't expect to enjoy like learning about registries and subdomain this much. I might just go starting handing out some free.subdomains.eth like candy now.
I'm glad. Yeah, I'm happy to go as high level or as technical as you'd like. And we'll be helping out during the hackathon as well. So
All right.
it sounds like you have some digging to do, but once you have more questions, we're happy to help.
Yeah, thank you.
Of course.
Yeah, you can always join the ENS Developers Telegram, as I shared before, and ask the questions there.
Yes, another way to find that is in the bottom page of everything on the docs, or the bottom of every page on the docs, right here.
Somehow we don't know how to reactivate the chat here in this webinar setup.
Yeah.
Yes,
I don't know.
sorry. For some reason, I don't know how it should work, but hey, if you have any other question, but the chat is, I think the chat is open. Sorry, Eric has a question. Yes. Sorry, at this stage, I think I just give you, Eric, you can talk, please.
Yeah, I see the question
read
as
out,
well.
like, okay.
Assuming I issue subdomains to my DApp users, now I want the users to use subdomains within my only. I don't know if this is possible since you said as long as the names have been issued, they can use it anywhere. So you want to basically build the usernames just for your application that don't work anywhere else, it sounds like. Yeah, I mean, ENS is meant to be this kind of universal profile that works everywhere. I would say that's really the value of it. And so if you want just private usernames, then ENS may not be the best fit for you. I would say typically when people are building crypto applications, part of the ethos is like composability and having something work everywhere. So if that's something that you're interested in, ENS is a great choice. But yeah, if you want something that only works within your own app specifically, then maybe ENS isn't the best fit for you.
Eric, does it answer your question? Are there any other questions? People also say thank you so much. Denison said thank you for everything.
Oops.
Thanks for joining.
Yes, guys, don't feel shy. I mean, do you have any other questions? Stay a couple more minutes. I think you can place the question in the Q&A session, or you can raise your hand as you wish, and we give you the mic.
That's all right. If
3,
people
2,
have
1.
questions,
Okay.
yeah, if they look into it more, we're always available to help. But I think for
Okay, I
now,
mean, okay.
good.
Okay, I think there are no other questions so far. I think you already shared the Q&A, the QR code, so you can join the Telegram group. Otherwise, we will also have all the documentation is going to be shared for the hackathon later on in the ETHAccra dashboard, so you have additional question. And I think Simon and Greg will be also at the hackathon, so you can also ask them questions or ping them on Telegram, etc. I really enjoyed this. As we can see, Michael was very intrigued to learn a lot. It's good to see that it resonates with the interest of the people. And also thanks for Simon and Greg for taking your time, sharing your expertise and knowledge. It's always a pleasure. I think if you don't have anything, then I will close it very soon. Otherwise, you have any words that you want to share, Simon, Greg, you want to see how people can prepare? If you're excited, the stage is yours.
Yeah, I think read through the ENS docs, join the Telegram, ask us if you have questions. We'd love to help you come up with ideas for the hackathon, or help you debug as you're working on your project. And so we are, excited to support. But otherwise, thanks for spending the time to hang out here with us today.
Well said. Looking forward to see you in person. And yeah, happy hacking, play around with stuff. And don't be shy, come to the Telegram and ask questions. There are no stupid questions.
Godfred, he raised his hand. Okay. Godfred, you can speak now.
Thank you so much. Please can get the Telegram link again. I missed that.
Wait,
Yes.
I
don't know if we can share it in the chat because we can't seem to turn on the chat. But if you go to docs.ens.domains over here, and you go to any page, there will be a link to the Telegram group in the bottom left corner. And if you click this, you should be able to join. Yeah.
Oh, okay, great. Thank you so much.
Wait, I
Yep.
also have a hack. I can share my screen again.
Yes. Okay, now you see it.
It's a QR code on the right.
Thank you.
And for those that are on a mobile phone, maybe you want to do a screenshot now. We'll check it later. Yeah, we need to work on that chat. But also, maybe Abna, we can send an email to all attendees maybe tomorrow with the most important links.
Oh, yes. Yes, I think that would be great. We will do that. Okay, I think, yeah, we'll do a follow-up with the most important links. So have you prepared for everything. Thank you so much. It was a pleasure. I will close it. Bye. Thank you.
Bye, everyone.